Okay, students. Now in the same frequency response plots, now we'll see the next plot, which is nothing but a polar plot. Okay. Now what we covered so far is a Bode plot and a gain margin, phase margin calculations. Now similarly a polar plot. Now what is the polar plot? Now all the plots are the frequency response of open loop transfer function. This is also same. The polar plot is nothing but frequency response of open loop transfer function. The polar plot is the frequency response of open loop transfer function, G of S. A polar plot is the frequency response of open loop transfer function. Now, you just see here, this is the frequency response of open loop transfer function. But what is the polar plot? Now, before we start the actual polar plot, then I just want to give a small thing here. You know that this is 0 degrees, this is plus 90 degrees, this is plus 180 degrees, this is plus 270 degrees. 0 degrees, plus 90 degrees, plus 180 degrees, plus 270 degrees, plus 360 degrees, and so on. Okay, these are the lines. Now this is magnitude 1 circle, this is magnitude 2 circle, this is magnitude 3 circles. Okay, now these circles represents the magnitudes and these lines represents the phase angles, and this one is 45 degrees and this one is 225 degrees. Let us see here. Okay, so this circles represents the magnitude, this radial lines represents the phase angles. Then you touch any particular point on this particular graph. Then if I touch here 3 at angle of 90 degrees, if I touch here 3 at angle of 0 degrees, if I touch here 2 at angle of 45 degrees, if I touch here 1 at angle of 270 degrees, if I touch here 3 at angle of 180 degrees, if I touch here 1 at angle of 180 degrees, which means what? If you take anywhere on this particular graph, here and here or whatever it may be, now you can have two values. One is magnitude, another one is phase. Okay, magnitude and phase angle. Then if you take anywhere, this is the magnitude, phase angle, magnitude, phase angle, magnitude, phase angle. Am I not? Now this particular sheet is called as a polar sheet or polar graph. In polar graph, this circles represents magnitudes, the circles represents the magnitudes, and this radial lines represents the phase angles. Now this radial lines represents the phase angles. Therefore the polar plot is nothing but magnitude and phase angle plot. Therefore, what is another name of polar plot? Polar plot is the frequency response of open loop transfer function, and a polar plot is also named as the polar plot is the frequency response of open loop transfer function. Therefore, the polar plot is also called as magnitude phase angle plot. Magnitude and phase angle plot is nothing but a polar plot. So the polar plot, another name is magnitude and phase angle plot, which is the frequency response of open loop transfer function. Now in all these particular magnitudes, now see here, this is 0 degrees. In 0 degrees phase angle, where is the magnitude 0? This is magnitude 1, magnitude 2, magnitude 3, magnitude 0 is here. In 90 degrees, magnitude 0 is here. In 180 degrees, magnitude 0 is here. 270 degrees, magnitude 0 is here. 45 degrees, magnitude 0 is here. Now in all the phase angles, if the magnitude is 0, that is available and existing at origin. Okay, remember this point. Now all the phase angles, the magnitude is 0 is nothing but at origin. Okay, so this is the polar graph. Actually we want to draw the polar plot on this particular polar graph, but now we are not bringing any polar graphs or polar sheets. In the examination also, in GATE examination also, no polar graphs and polar sheets. Now in the paper itself you can be assumed. Now our paper, our plain paper itself, you can be treated, oh, this is a polar sheet, This is a polar graph. We have all angles. We have all phase angles. Then we will try to draw the polar plot. Okay. Now note down this. The polar plot is nothing but magnitude and phase angle. But this is the frequency response. Therefore, how we are linking the definition of a polar plot? Magnitude and phase angle of open loop transfer function as frequencies varied from 0 to infinity. What is the polar plot definition? Now the polar plot is nothing but magnitude and phase angle of an open loop transfer function as frequencies varied from 0 to infinity. This is nothing but a polar plot definition. Polar plot is magnitude and phase angle of an open loop transfer function as frequencies varied from 0 to infinity. So if you touch anywhere on this particular graph, no two readings, we have three readings. Magnitude, phase angle at some particular frequency. Magnitude, phase angle at some particular frequency. Magnitude, phase angle at some particular frequencies. Okay. So we want to draw the polar plot, a magnitude and phase angle as frequencies varied from 0 to infinity. We will try to draw the approximated polar plot. But this is the polar sheet now, and a polar plot is called as magnitude and phase angle, which is the frequency response of open loop transformation. First, you note down this. Okay. So now we will draw the polar plot, which is the magnitude and frequency response of open loop transfer function. So if you know how to calculate the magnitude, if you know how to calculate the phase angle, this plot, which is very simple plot. Now we will try to solve one by one. Now let us take one small problem, g of s, which is equal to 1 by s plus 1. Now you just first follow what is a general procedure, okay? That will be the standard procedure for any problem. Now first replace s equal to j omega. This is the frequency response. Replace s equal to j omega. 1 divided by 1 plus j omega. Now what is the magnitude? Now 1 divided by 1 plus j omega, magnitude. Magnitude is nothing but 1 divided by square root of a square plus b square. Now denominator, therefore phase angle is minus tan inverse imaginary part by real part. Now students, now first what you should do is, whenever you find the magnitude, whenever you find the phase angle, now first you should be identify that your phase angle is independent of frequency or depends upon frequency. Of course magnitude is also you can check, but the important parameter here is phase angle. Now your phase angle is independent of frequency or depends upon frequency. Now this is the phase angle. Now this phase angle is depends upon frequency or independent upon frequency. This is completely depends on frequency omega. So first you can identify the phase angle is independent or dependent. Now the phase angle is dependent, then the problem is starting, because practically how many frequencies are existing? Practically the frequencies are existing from 0 to infinity. Omega 0, omega 1, omega 2, omega 3, omega 4. Is it possible to calculate infinity magnitudes and infinity phase angles? No. Practically, it is not possible to find the infinite parameters by changing infinite frequencies, by applying infinite frequencies. Therefore, we will try to draw the approximated polar plot. At least a few frequencies you can calculate, at least the starting and at least the ending. Starting is nothing but omega 0, ending is nothing but omega equal to infinity. Now see here. Now, when omega equal to 0, magnitude is, when omega equal to 0, 1 divided by 1 plus 0, 1, phase angle is 0 degrees. When omega equal to 1, when omega equal to 1 by 1 plus 1, 1 by root 2, phase angle is tan inverse 1 means 45 degrees, minus 45 degrees. Now, as frequencies varied from 0 to infinity, and so on and so on and so on, when omega equal to infinity, when omega equal to infinity, something by infinity, so the magnitude is 0, phase angle is tan inverse infinity, 90 degrees. This is minus 90 degrees. Okay. So, as frequency is changing from 0 to infinity, now this is the magnitude, this is the phase angle. So, as frequency is changing from 0 to infinity, then you know the magnitude and phase angle. Now, you will try to draw the polar plot. Then only two steps you should remember. First, indicate the starting angle and next indicate the ending angle. Now, see how I am writing. What is the starting angle? Starting angle is 0 degrees. Starting angle is 0 degrees. Now, what is ending angle? Ending angle is minus 90 degrees. Now, you just see here, if phase angle is independent, now you may write like this. So, you should start 0 degrees and go to minus 90 degrees. So, can I go like this? Some of you are writing like this. Now, when you can go like this, you can go like this when your phase angle is everywhere 0 degrees, 0 degrees, 0 degrees. Therefore, I can go in this way. But your phase angle is completely depends upon frequency. As frequency is changing, your phase angle is changing. Therefore, there is no shortest path. You should take a long path, long drive from 0 to minus 90 degrees. Therefore, in 0 degrees, what is the magnitude? 1 at angle of 0 degrees when omega equal to 0. One at angle of 0 degrees when omega equal to 0. 1 at angle of 0 degrees when omega equals 0. Now 0 to minus 90 degrees. Now 0 degrees to minus 90 degrees. So we can go like this. Now your journey starts at 0 degrees and go to minus 90 degrees. In minus 90 degrees, what is the magnitude? In minus 90 degrees, the magnitude is, in minus 90 degrees, magnitude is 0. Therefore, is at origin. Therefore, now you should see here, this is 0 at angle of minus 90 degrees when omega equal to infinity. And in polar plot, the important point you must and should indicate the direction. Now, the direction is nothing but as frequency is changing from 0 to infinity. This direction indicates as frequency is changing from 0 to infinity, 0 to infinity. Now, this is the polar plot. So, as frequency is changing, when omega equal to 0, magnitude is 1, but phase angle is 0 degrees. In 0 degrees, magnitude 0 means at origin, but magnitude is 1 means somewhere, you write somewhere approximately, okay? So, 0 degrees, your journey is starting and your journey is go to minus 90 degrees and your phases is completely changing from 0 to minus 90 degrees, and that too, these are the negative angles. The negative angles means this is the clockwise direction, right? So, 0 degrees to minus 90 degrees. In minus 90 degrees, magnitude is 0, which is available at origin. So, this is the polar plot of one simple pole, one finite pole. Simple pole, finite pole means what? Simple pole, finite pole means it must and should lies on left hand side of S plane. S plus 1 equal to 0, S equal to minus 1. S equal to minus 1 means it lies on left hand side of S plane. If it is any pole or any 0 which is lies on left hand side of S plane, now that poles and that zeros are called as simple poles or simple zeros or finite poles or finite zeros. You know that, okay? In Bode plot also we will discuss this one, okay? Now this is the simple pole or a finite pole. One simple pole, one finite pole. This is the polar plot. Then you have some doubts that this is correct or not. So this is 0. This is minus 90 degrees. Then in between, then this is a minus 45 degrees line or not? Now this is a minus 45 degrees somewhere. This is minus 45 degrees. Now in minus 45 degrees, yes, there is a magnitude. There is a magnitude of 1 by root 2. Okay. So this is the polar plot, and this is the way you can draw the polar plot. There are 4 steps: magnitude, phase angle, omega 0, omega infinity. See the starting angle, see the ending angle. If your phase angle is dependent, definitely polar plot is not a straight line. It is a long path. Okay. Note on this. Okay, now this is the procedure of drawing any polar plot. But without direction, there is no meaning of the polar plot. First, you must and should draw the direction of the polar plot. Now, this is the polar plot of one simple pole. Now, the same question I am asking. Now, what I am doing is g of s, which is equal to 1 by s plus 1 is already there. Then I add one more finite pole, s plus 2, means s equal to minus 2. I just add one more finite pole. Now what happened? Now same procedure without any deviation. G of j omega, which is equal to 1 divided by 1 plus j omega, 2 plus j omega, 1 plus j omega, 2 plus j omega. Magnitude is 1 divided by square root of a square plus b square, square root of a square plus b square. Phase angle is denominator, therefore minus tan inverse omega by 1 minus tan inverse omega by 2. Minus tan inverse omega by 1 minus tan inverse omega by 2. Therefore, now as phase angle is completely depends upon frequency, the phase angle is completely depends on frequency. Therefore, polar plot is definitely not a straight line. Phase angle is completely depends upon frequency. Therefore, polar plot is not a straight line. Therefore, now you should be take when omega equal to 0, something by 0, infinity. 0, 1 by root 4 means 0.5 at angle of 0 degrees, and so on and so on. When omega equal to infinity, something by infinity, 0, phase angle is tan inverse infinity 90, tan inverse infinity 90, minus 180 degrees. Now again same procedure. First take the starting angle, next take the ending angle. What is the starting angle? Tell me. Starting angle is 0 degrees. Next ending angle. What is ending angle? Students, remember once again. Okay, I'm explaining the same. Now starting angle is 0 degrees. Ending angle minus 180 degrees. Now in 0 degrees, what is the magnitude? 0.5. In 0 degrees, if the magnitude is 0, which is available at origin, but this is not origin because some magnitude is existing. Somewhere you write 0.5 at angle of 0 degrees when omega equal to 0. Now your journey starts at 0 degrees and go to minus 180 degrees. Therefore, it is not a straight line. It is a long path. The straight line and a shortest path is coming everywhere, 0, 0, 0, 0 or 90 degrees, 90 degrees, 90 degrees, independent of frequency. Understand or not? So, in 0 degrees, your journey is starting and you go to minus 180 degrees. So, you must and should cross minus 90 degrees and go to minus 90 degrees. In minus 180 degrees, what is the magnitude? In minus 180 degrees, magnitude is 0. Definitely, it is available at origin. 0 at angle of minus 180 degrees when omega equal to infinity. Now this is the direction as frequencies varied from 0 to infinity. As frequencies varied from 0 to infinity. Am I right or not? So magnitude, phase angle, omega 0, omega infinity, starting angle, ending angle. Now how you should move? You move to a shortest path or a long path. That is the way to draw the polar plot. Understand or not? Now same. Now G of S. See. Now what you observed here? What is our observation in these two problems? Okay. Now this is one finite pole, S plus 1. Now here you should add one more finite pole. S plus 1 is already there, but you should add S plus 2. So the addition of each finite pole, what happened? The addition of each finite pole, what happened? Now if you see the polar plot, what is the starting angle here? 0 degrees. What is the starting angle here? 0 degrees, no change. But what is the ending angle? Now see here, the ending angle is minus 90 degrees. This is the ending angle. But what is the ending angle here? Here the ending angle is minus 180 degrees. Now this is minus 180 degrees. So what is your observation? By add a one finite pole, the addition of each finite pole, note on the student, this is very important. The addition of each finite pole, shift the, not the starting angle, only shift the ending angle by how much? Minus 90 degrees. Minus itself is which direction? Minus is nothing but a clockwise direction. Plus is nothing but anti-clockwise direction. Okay, this is one important note here. The addition of, what is the note? The addition of, I will write the notes here. Okay. The addition of each finite pole, shift the ending angle of the polar plot, shift the ending angle of the polar plot by minus 90 degrees. Minus itself, minus means clockwise direction, plus means anti-clockwise direction. You know this. Okay. Now this is the note you observed. The addition of each finite pole. So without drawing the polar plot, without finding the magnitude and phase angle, now you tell me what is the polar plot of 1 by S plus 1, S plus 2, S plus 3? Definitely the polar plot of 1 by S plus 1, S plus 2, S plus 3. Now without finding the magnitude and phase angle, I can easily saying that starting angle will not shift, but ending angle is shifted by minus 90 degrees. Now here it is minus 180 degrees. It shifted by again minus 90 degrees. So minus 270 degrees. Like this, this is the polar plot. Yes, definitely this is the polar plot of three simple poles, and addition of each simple poles will get that result. Okay, note on this. So do you understand or not? Then if you add one more finite pole, then again ending angle is shifted by minus 90 degrees. So then we'll take one more problem here. Now G of S, which is equal to 1 by S into S plus 1. Whatever may be the problem, then you should follow the same procedure for all the problems. Now replace S equal to J omega. 1 divided by 0 plus J omega, 1 plus J omega. Now what is the magnitude? 1 divided by square root of A square plus B square, square root of A square plus B square. Phase angle is denominator, therefore minus tan inverse imaginary part by real part. Tan inverse imaginary part is omega, real part is 0. Tan inverse omega by 0. Tan inverse infinity. Tan inverse infinity is minus 90 degrees. Means minus tan inverse omega by 0. Minus tan inverse infinity. Means minus 90 degrees. That I can write directly. Okay. Minus 90 degrees. And minus denominator minus tan inverse omega by 1. Okay. So this is the phase angle, and immediately you can have one idea. Now your phase angle is depends. Your phase angle is depends. Polar plot is not a short path. Polar plot is a long path. So your phase angle is depends on frequency. Your phase angle is depends upon frequency. Polar plot is not a shortest path. Therefore, when omega equal to 0, something by 0, infinity at angle of something by 0, infinity at angle of minus 90 degrees, and so on and so on. When omega equal to infinity, something by infinity 0, something by infinity 0 at angle of tan inverse infinity 90 minus 90 minus 180 degrees. Same. What is the starting angle? The starting angle is minus 90 degrees. First minus 90 degrees line. Ending angle is minus 180 degrees. So in minus 90 degrees, where is the magnitude? In minus 90 degrees, magnitude infinity means somewhere around here in the minus 90 degrees, infinity. Okay. So somewhere you write. Okay. This is when omega equal to 0, infinite at angle of minus 90 degrees. Now your journey starts at minus 90 degrees and go to minus 180 degrees. Not shortest path, is a long path. And in minus 180 degrees, what is the magnitude? In minus 180 degrees, the magnitude is 0. In minus 180 degrees, magnitude 0 is available at origin. 0 at angle of minus 180 degrees when omega equal to infinity. As frequency is changing from 0 to infinity, 0 to infinity, 0 to infinity. So this is a polar plot. So you just observe here, you just observe these plots, you can easily get some relations. Okay, that relations are important because while adding zeros what happen, while adding poles what happen, what should be the changes in the polar plot, that questions which are very, very important. Okay, just note down this. Right. Now this is a general procedure how to find the magnitude and phase angle and by varying the frequencies from 0 to infinity. Sir, then is there any shortcut method for this particular drawing of the polar plot? Yes, there is a shortcut method. Okay, but you should be follow the standard procedure, because now that standard procedure you can understand, then even if the shortcut methods are sometimes it will not work, then you can easily go through this with the standard procedure. Okay. But anyway, I just give one shortcut method which is very useful to you. You just follow this. Now this is type 0 system. This here is the type 1 system. Here is the type 2 system. Here is the type 3 system. Here is type 4, type 5, type 6. Like this, you just move the clockwise direction. Okay. Type 0, type 1, type 2, type 3, type 4, type 5, type 6, and so on. Okay. And see how I am writing. In one coordinate, only one type. Now in this coordinate, don't take two types. Take only one type, type 0. In this coordinate, only one type. In this coordinate, only one type. In this coordinate, only one. Don't write here type 0. Don't write type 1 here. This will give the wrong results. Okay. So in one coordinate, only one type and clockwise direction. Okay. Now in the same manner, now in one coordinate, one order. So this is order 1. This is order 2. This is order 3. This is order 3 and this is order 4. Order 1, order 2, order 3, order 4 and so on. Okay. Just note down this. Now students, you just see here. Now this is the type and this is the order, where order represents ending of the polar plot. Okay, what is this? Where this order represents ending of the polar plot. This order represents ending of polar plot. This type represents starting of polar plot. Okay. So starting of polar plot is given by type. Ending of the polar plot is given by order. Then this will work or not, we will check. Now, how many poles at origin here? Now see the students. How many poles at origin? No pole at origin. Type 0 system. Type 0 means where it will start. Type 0. Here it starts. Here it starts. Is correct or not? Order. Highest power in the denominator polynomial. 1. Order 1 means order is the ending. Where it will end. Here it is ending. Here it is. Same answer or not? Now we'll check one more problem. How many poles at origin? No pole at origin. Type 0. Type 0 means where it will start. See here. You just cross check. Type 0 is starting here. Here it will start the polar plot if it is a type 0 system. Yes, this is a type 0 system. Here it is starting. And what is order? The highest power in the denominator polynomial is 2. Order is 2. Therefore, order is the ending of the polar plot. Now this is the ending of the polar plot. Is matching or not? Here. How many poles at origin? 1 pole at origin. Now this is type 1. See here, you cross check. This is type 1. Yes, here it will start. Order is 2. Order 2. Order 2 means here it is ending. Order is ending. Here it is ending. Is matching or not? So type represents the starting of the polar plot. Order represents the ending of the polar plot. So then why unnecessarily wasting of our time to draw this polar plot by finding magnitude, phase angle, frequency and all these things? No. So this is the shortcut method which is valid with one condition. The condition is nothing but here. This type order method, here I will write one note. Type and order shortcut method is used only when the transfer function having denominator polynomial. Understand or not? Means what? If the transfer function is having only denominator polynomial, means only poles. If the transfer function is having only poles in the denominator, then use this type and order approach. Don't use when the transfer function is having zeros. If the transfer function is having zeros, numerator polynomial is available. Don't use this type and order concept, then it will give the wrong results. Understand? No? This type and order concept is used only when the trans function is having denominator polynomial. If any numerator polynomials are also available, zeros are also available, don't use this method. Use your general procedure: magnitude, phase angle, omega 0, omega infinity. Understand? No? This is very, very important. Definitely, practical systems are what? Practical systems are nothing but number of poles is greater than number of zeros. Definitely it will work. Okay, it is useful to you. Okay, so if it is only denominator, you can use this shortcut method straight over. Okay, hold on this. Okay, now you follow this type and order method when the transfer function is having only denominator polynomial. Okay, otherwise don't use this. Go for your normal procedure. This type and order method is used only when the transfer function is having denominator polynomial. Now, sir, is there any other shortcut methods? Okay. Now, before that, then from these particular problems, what you observed? See here. This is one problem. You just see here. This is problem number 1. Let us assume this is number 1 problem. And see, this is number 2 problem. What is the relation between 1 and 2? This is one simple pole is already available in the transfer function. So in the same transfer function, what you should do? You just add one pole at origin. This is the problem, and this is the same problem, but you just add one pole at origin. Then what is your observation? Now the polar plot is like this. See here, see the students, the polar plot is like this, right? This is the polar plot when g of s equal 1 by s plus 1. Then what should you do? You just add one pole at origin. You just add one pole at origin. The total polar plot is shifted by like this. See here, this is the original polar plot. Then you add one pole at origin. This is the polar plot. Means what? So this is the original polar plot. Then you add one pole at origin. The total polar plot is shifted like this. Means the addition of each pole at origin shifted by, see here, shifted by how much? Minus 90 degrees. Minus means in which direction? Clockwise direction. So can I take that note also? The addition of each pole, the addition of each pole at origin, the addition of each pole at origin shift not ending angle, not the starting angle, shift the total polar plot, shift the total polar plot, shift the total polar plot by minus 90 degrees. Is it right or not? Minus 90. Minus 90 degrees itself is a clockwise direction. Okay. Minus 90 degrees, which is nothing but the clockwise direction. Now, so then is there any other shortcut methods? Now I will try to find the shortcut methods here. Now, starting direction. Sir, is there any shortcut method for starting direction? How I can identify? Yes, there is a shortcut method for the starting direction identification. Now see here. If the transfer function having only finite pole, if the transfer function is having only finite pole, starting direction is clockwise direction. Clockwise direction. If the transfer function having only finite zero, then the starting direction is anti-clockwise direction. Anti-clockwise direction. Sir, is this statement is correct or not? Then we will cross check. Now, finite pole, I am already explaining. Finite pole means only left hand side. Finite zero means only left hand side. Yes. Now see here. This is the finite pole. Only finite pole. Only finite pole means what he is saying. Starting direction is clockwise. What is the meaning of starting? Starting means omega equal to 0. Omega equals 0. At omega equals 0, this is the starting direction. Which direction? The starting direction is which direction? Students, tell me. Which direction? Clockwise direction. This is the clockwise direction, starting direction. This is also finite pole. Only finite poles. S equal -1, S equal -2. Only finite pole means starting direction. Again here you see. This is the starting direction. Which direction? This is the starting direction, which means that clockwise direction. Is it correct or not? Again here is also finite pole. S plus 1 equals 0. S equal to -1, finite pole. If it is a finite pole, what is the starting direction? See here, starting direction means omega equal to 0. The starting direction is the direction at omega equal to 0. So at omega equal 0, starting direction is clockwise. This is the starting direction, clockwise direction. This is the starting direction, clockwise direction. This is the starting direction, clockwise direction. Because finite pole, finite pole, finite pole. Clear or not? So this is the starting direction. If really the transfunction is having only finite 0, then definitely the starting direction is anti-clockwise direction. In our problem, you cross-check that one also. If the transfunction is having finite 0, then the starting direction is anti-clockwise or clockwise, you can check. But the students are smart and asking that if the transfunction is having both, if the transfunction is having sometimes both pole, finite pole and finite 0. So S plus 1 by S plus 2, like this. And sometimes S plus 2 by S plus 1, like this. Finite 0, finite pole. Finite 0, finite pole. All are left hand side. Both are available now. So what I am saying here, if it is having only finite pole, only finite 0, clockwise, anti-clockwise, but it is having both. So in such a situation, sir, what should we do? You just see the poles and zeros in a plane and just identify which pole is nearer to the origin and which is nearer to the origin. Now this is a finite 0. Here, this finite 0 is nearer. This finite 0 is nearer to the origin. This is the nearer to the origin. Therefore, starting direction is anti-clockwise direction. Anti-clockwise direction. Finite 0 is nearer to the origin. Therefore, starting direction is anti-clockwise direction. Now here, finite pole. This is the finite pole. Finite pole is nearer. Finite pole is nearer to the origin. Finite pole is nearer to the origin. Therefore, starting direction is clockwise direction. Starting direction is clockwise direction. Okay. So, if the finite 0 and finite pole both are available, depends upon the pole or depends upon the 0, which is nearer to the origin. Who is nearer to the origin? That direction will be the starting direction. Who is nearer to the origin? That direction will be the starting direction. Right? So, these are the shortcut methods. Don't blindly follow those methods. Your diagram, your polar plot is correct or right or wrong, you have having some confusion. Now in such a situation, use these methods and such that you can get, yes, my plot is correct, yes, my plot is correct, then you can have some confidence. Okay. So all these shortcut methods which are very useful to you to draw the polar plot or which of the polar plot is correct also useful. Okay. And note down the observations also important. What happened zero origin? What happened pole at origin?